We would all like to welcome you all to this Christmas transmission of Christmas message. I would like to introduce you to my colleagues. We have Jan-Åke on my right side, who will be the operator today, and Kai on my left side, who is the telegraphist, and he will send the Christmas message. My name is Robert, and I will be your host during today's transmission. We will soon start the transmitter, and we have done some preparation in advance by applying the full voltage into the station and checked all the oil levels and also connected the transmitter to the antenna with some knife switches. So just a quick description of the machinery. We have the 2000 volts, which feeds a motor, an electrical motor, who drives the alternator, which is the high frequency generator, through a gearbox which increases the speed of the rotation. From the alternator, we are connected to high frequency transformers and a magnetic modulator, and through a variometer we have a connection with a multiple tuned antenna. So now it's time to switch on the power to the station. And Jan-Åke will be positioned at the emergency switch if something goes wrong. And I will switch on the power now. And now we can hear the alarm bell, which tells us that we have no oil pressure and no water pressure. And the alarm bell will now be switched off by Jan-Åke. And the next step now is to start the water pump, which is used for the cooling of the alternator and other equipment. The first step will be to open the water valve and fill up the pump with water and to bleed off the air of the pump house. And Jan-Åke is doing that at the moment. So he listens so he can hear that there are no air in the water that is bleeded off at the moment. It's a centrifugal pump, so he will start there with it's a three-phase motor, and there is a star delta starting equipment. So it's a two-step start. And then he will open the main valve, and the pressure will rise to about 2 bars, which you can see on the right-hand meter on the wall. And there are a lot of turns on the handle for the valve, so it takes some time to open it, and it's quite hard work. And now we can see that the water pressure is increasing, and it looks like it's coming up to the right level. The cooling water is used to cool, among other things, the liquid resistors, which is a way to control the speed of the motor. And it's quite some heat generated in the liquid rheostats, which contains a soda type of water, so it is slightly conductive. So now Jan-Åke will switch on the circulating pumps in the liquid rheostats, so we will avoid the boiling of the liquid when the motor starts. So it's a special arrangement with the contactors here that we have a wooden block, so we can start the circulating pumps before the motor starts. So you can hear now and also see on the video that the liquid is circulating inside the rheostats. So now we will switch on the alarm bell again, and then we will start the external oil pump for lubrication of the main motor and alternator. So now it's time to start the motor, so Jan-Åke goes to the emergency switch again and signals to me when he's prepared at the switch. So now he signaled that it's okay to start the motor. And now the motor and alternator are slowly starting to increase its speeds. The motor will, when it's up in speed, it will rotate at 711 revolutions per minute. So we have a starting current just when the power is applied to the motor of about 140 amps. And now it's slowly dropping down. So we will apply full power to the motor when we are at about 80 amperes. And after a while, we get a warning signal that the oil pressure is getting too high, and then we'll switch off the... So that's the case now. And you can now hear the speed of the motor and alternator increasing. And at some stage we need to apply the full power to get up to the full speed. We are at about 90 amperes at the moment for the motor. So we wait a little bit longer, so we allow it to drop a little bit more. And now Jan-Åke will switch on the rectifiers, which provide power to control the voltage to the motor. So now Jan-Åke applied full power and is reducing the resistance in the liquid rheostats. And that is done by increasing the height of the water level, which you can see on the video as well. And at the speed of around 700 revolutions per minute, we will apply the field current to the alternator. And at that moment, it will start to generate the RF signal. But it's not yet connected to the antenna. Yes, and we can increase the start resistor a little bit to get some more power to the motor. I think you can even go up a little bit more. Yeah. And now we're waiting for the speed control to take control of the speed. And we can now see that we're within the regulation region, control region of the speed regulator. Yeah. And now we will get a speed, or we're actually looking at the frequency, which should be 17.2 kilohertz with quite some accuracy. And we will also allow the setup or the machinery to warm up for some time and do some initial fine-tuning. And at a little bit later stage, we will connect the antenna to the alternator and do some fine-tuning of the resonance of the antenna itself. I think it's now time to turn on the fan, the cooling fan. And we can now see that the speed is very close to 17, or the frequency actually, it's 17,195 hertz. 17,195 hertz at the moment. And before we can start to key the transmitter, we will, well, Jan-Åke was starting the air fan, which is used to cool the contactors which carry a heavy current. And it's also cooling the contacts, and it's also blowing out the sparks. If the fan is not switched on, these contacts will quite quickly be destroyed. Yeah, I think we now have the correct frequency, and now we can attach the alternator to the antenna system. And now the night switch is connecting, so it's the alternator is now giving a signal out into the air. So now if you have a radio to receive the signal, you can hear the signal from the transmitter at the moment. So now Jan-Åke is doing some fine adjustment to the control or the liquid resistor that is switched on when the Morse key is held down, and we get the signal into the antenna. So we need to adjust that we have the right speed when the key is not pressed, and then we need to adjust the speed when the key is pressed to keep the same frequency. So now we'll switch on the paper tape reader, where the identification of SAQ, which is the signal name of this transmitter. So this is now transmitting into the air. And I will ask Jan-Åke about what antenna current we did have. Vad fick vi för ström? Antennström när den går? Ja, nej, vänta lite. And now we are waiting to dry the antenna a little bit, our insulators. And also there could be some snow and so on the wires on the antenna, which would affect how much power the antenna will accept at the moment. We also have a variometer, which is a variable inductance, which is connected in series with a feed to the antenna. So we will adjust the tuning of the antenna a little bit later on. My cameraman and I will go outside to take some views of the antenna system. So you can look on the scenes on the screen here, and you don't need to follow us out. And here we can see the antenna system, which consists of 6 towers. And normally you think that the tower is the part of the antenna, but it actually only holds up the wires, which connect all the antenna wires together. The actual antenna which radiates the signal are a vertical wire at each tower, and the 8 wires on the top only distributes the current from the transmitter to all 6 vertical antenna wires. At the bottom there is a big coil which is used to tune the antenna to the correct frequency. And you can see the first coil in the camera at the moment. It's quite a high inductance, and it's connected together with the top wires. They act as a resonant system, which is fairly narrow band. So the antenna has to be tuned, which we do with the variometer during the transmissions to the exactly correct frequency. And the antenna coils, which are at the 6 towers, have been adjusted previously in advance to this transmission. We have a cooling pond out here, which can be used during very hot summer times if the transmissions are longer in time. As we run the transmissions now for a rather short time, we have or use only the internal water reservoirs, which are, I guess, a few cubic meters each. So that is used. And you can also see some wires which are just a few meters up in the air in the vicinity, which are part of the ground system. It's an extensive grounding system to the antenna. So I think we go back inside now. Vad för något? Två. So now we will see how Jan-Åke is doing with the frequency. Quite happy now with the output power and the stability of the frequency. So we will continue to allow the machinery to warm up even more. And we think we have a good setting of the controls at the moment. And we can see on the video here on the screen that the frequency control is working. We can see the gauges moving up and down in a quick fashion, which shows that the speed control is working. And we can also see that the voltage of the motor is around 2000 volts at the moment, which is the operating center, so to speak. And the speed of the motor is correct. It was the history of this historical transmitter, which is now a World Heritage, started in after the First World War, when the government understood that there need to be some other means than cables under the Atlantic to be able to communicate. So they decided in 1921 that the transmitter should be built somewhere on the west coast. And in October 1922, the survey to find a suitable place to build to construct the transmitting site was undertaken, and it was decided that it should be built here in Grimeton, which was a very good place. There were you have to have compromises between you don't need to be too close to the sea, to the beaches, because you could be reached by artillery from battleships. So this is a good place, sufficiently far away from the sea. And the construction started and went on quite rapidly, and it was finalized in about 2 years. And the first test transmission was carried out in October 1924. And the first commercial transmission was done in 1st December 1924. And went on for about 30 years with daily transmission. At the end of 1950s, the traffic was more and more taken over by shortwave transmitters. As you can see inside this hall, we have a number of transmitters within this site, which you can see on the window side of the hall. During the Second World War, I guess you more or less all know that there was a Swedish submarine that was out on an exercise close to Gothenburg, or a little bit north of that. And that was not returning to base after the exercise. And after some time, it was understood that the U-boat had some problems, and they were trying to be contacted by this Grimeton transmitter, because it's so low frequency that is used, 17.2 kilohertz, that it can protrude into the seawater to quite some depth. I guess 10, 20, 30 meters perhaps. But there was no sign of the U-boat, and it was later found that they had run into a mine, and everybody was killed. And it was later decided that this station would be used to have a connection with submarines in the Swedish Marine. Later in 1990s, there was no use of this very long wave transmitter anymore, and it were quite a risk that it would be scrapped. And at that time, the Alexanderson Association was founded, and were working to preserve this transmitter in working order. And you can see the results of this. And we do about 3 transmissions onto the air every year. And it's run without connecting to the antenna quite a lot. Yeah. Now we have 5 minutes left before the actual transmission will start from by Kai, and he is using an ordinary Morse key to transmit the message. But we are still about 5 minutes to wait for that. The actual keying of the transmitter with the Morse key, it controls a current through a special type of inductor, which is called a magnetic amplifier, which is connected to the high-frequency transformer, and it makes the antenna system together with the high-frequency transformer and the variometer to be tuned to the right frequency and off the right frequency. So when the Morse key is not pressed, the system is tuned off frequency, so we don't get any signal into the antenna. And when the key is pressed, we get the resonance of the antenna system together with the RF transformer to the right frequency, and we have the high power directly into the antenna. So there is a difference. It still leaks out a little bit of a signal when the key is not pressed, but it's about 100 times less power when the key is compared to when the key is pressed. Några minuter kvar. Now we are about 1 minute to go to the transmission. And now Kai is switching over to his Morse key. Thank you, Kai, for this transmission. Very well done. Now we will go to switch off the transmitter. So I will ask Jan-Åke to lower the two switches. Yes, and now you can hear that the motor is reducing its speed. And then we will stop the motor. Stänger av, yeah, you can use that. Den hårdare, harder. Good. So now the motor is completely switched off, and it will take about 9 minutes before it's come to a complete stop. And Jan-Åke is now setting the liquid rheostat into its starting position, so we are ready to go for the next time. So thank you all for attending this Christmas transmission. We wish you all of you, a Merry Christmas and a Happy New Year. If you have listened to the on-the-air transmission, we are happy to receive QSL confirmation of your report. We also hope that you will become a member of the Alexander Association, where our main tasks are the maintenance of this excellent equipment and to conduct transmissions a number of times each year. It's done on a voluntary basis, and we are all who is working with this very happy to have the opportunity to do this. So thank you very much, and goodbye. On